All right, so now we're going to talk about something different. Remember, everything we've been talking about has involved what kind of triangles? Right triangles. Good. Now we're going to move away from the concept of right triangles. So if I don't have a right angle in my triangle, what kind of angle do you think I might have? An obtuse angle, okay? Or I could have multiple acute angles, okay. Let's take a look at. So let's talk about the law of sines. That's what we're going to use in order to solve our oblique triangles. And what do I mean by oblique? I mean a triangle that does not have a right angle in it. Okay, so if you hear me say oblique, that's what I'm referring to. So here's the law of sines. Go ahead and add this to your notes. If I have three angles, A, B, and C, and I have three sides that are opposite these angles, then my formula is the ratio of the length of the side of any triangle to the sine of the angle opposite the side is the same for all three sides of the triangle. So here's my formula. A over the sine of A equals B over the sine of B equals C over the sine of C. All right, here's a variation of the same formula. It's the same thing, except what did I do? I flipped the fractions over. And typically you want to, depending on what you're looking for, whether you're looking for sides or if you're looking for angles, that's how you're going to set up your ratios, okay? So if I'm looking for an angle, I'm going to put sine of A in the numerator. If I'm looking for a side, I'm going to start with little a over sine A. So I'm going to use this setup if I'm looking for a side. And I'm going to use the setup at top if I'm looking for angles first, or angles, just in general. Alright, so here are some different representations of oblique triangles. So notice that here I do have those acute angles, right? And then in here I have one obtuse angle. Okay, so where does this formula come from? Remember, sine of theta is opposite over hypotenuse. And if I solve both of these ratios for h, then I can set them equal to each other. And that's how we end up with the law of sines. That's the proof for the law of sines. Okay, so definition of an oblique triangle. Again, remember, it's a triangle that does not contain a right angle. If I don't have a right angle, it's really important to remember we cannot use the Pythagorean theorem, nor can I use any of those properties that I showed you up until this point. So everything we're doing now is a little bit different. So if you use the Pythagorean theorem to solve for sides, I will show no mercy. So make sure you know no right angle, no Pythagorean theorem. Okay, so now let's solve some oblique triangles. All right, we're going to have different types of givens for our oblique triangles. The first one we're going to talk about is the side angle angle triangle. So that means I have a side, an angle, and an angle. Okay? In this case, it's really easy to find the third angle. Well, how do I find the third angle? I do 180 minus 43, which is 137, minus 20 is 117. So here, angle B is 117 degrees, and there's no question that angle B is 117 degrees. It has to be that measurement, right? Okay. That's not going to be the case tomorrow, so it's important to understand this concept. When I have a side angle angle triangle, there's no question about this third angle. I just started solving my triangle. We found angle B equals, notice that I'm not writing approximately, 117 degrees. And now we want to set up using the law of sines to find our missing sides. Well, what sides are we missing? We're missing B and we're missing A. So we're going to set up the law of sines. So I'm going to do little a over sine 20, and you always set it up equal to a complete proportion. So notice that this ratio is complete. I have side C and I have angle C. So 32 over sine 43. Now cross multiply, move that over. Put this into your calculator, you're going to get 16.05. Let's find B together. So B over the sine of 117 equals, and for sake of consistency, God bless you, I'm going to use the same ratio. You could at this point, because we found A, use A over sine of A. It's up to you what you want to do. But here, just because I have this one written out, I'm going to go ahead and put this in. And now I'm going to multiply sine 17 to both sides. And we're going to get b equals 32 sine 117 over sine 43. Put this into your calculator, round to two place values. Notice that I did say that this was in inches. Alright, so our solution is 41.81 inches. Remember, here we're in degree mode. My triangles, clearly they give me degrees, so make sure that you switch the mode in your calculator. So let's take a look at what we're given here, and this is a triangle where we have angle, side, angle. So here's my given angle. My side is between two angles, so that's why the given is known as angle, side, angle. And then we can do a little arithmetic to find our missing angle. So we're missing b. So we're going to do a plus b, or 180 minus 34, and then minus 72, and we get 74 degrees. So angle B is 74 degrees. So now I have a complete proportion. This is my complete proportion. Side B over angle B. And that's what you see me setting up over here. Side B over angle B. Let's look for C. So C over sine 72. Cross multiply here, and we get side C is 69.26. So now I have two complete proportions that I can manipulate if I so wish. Let's find little a. So little a over the sine of a. Sine of a, 34 degrees. Here I have an option. Either I can use the same ratio I did before, or I can use the one I just found for C. So I can use this one if I so wish. However, I'm going to keep it consistent. Let's just do 70 over sine 74. Multiply sine 34 to both sides. Put this into your calculator. Let's round to two place values. A is approximately. Yes, our answer is 40.72. It doesn't tell us that it's inches, so let's leave it alone. Units. Alright, so here the instructions say for the given triangle, find the length of side A. But I want to switch these instructions. Let's say solve the triangle. When we're solving the triangle, we're looking for all the missing sides, all the missing angles. So let's start with the angles. Okay, so I have 180 minus 79 is 101. 101 minus 35 is 66 degrees. Okay. Alright, so now we're interested in little a or little b. So my complete ratio is this one. Because we're looking for the sides, I'm going to go ahead and set up the ratios for both. Okay, so we're looking for little a over the sine of angle A is 35 degrees. And we're looking for little b in the sine of 66 degrees. And I'm going to set them both equal to the complete ratio. You could do one at a time, but I'm setting them up both up at the same time. So here I'm going to set up 21 for the side, sine 79, and the same thing here. So here if I'm looking for A, I'm going to get A equals 21 sine 35 over sine 79. And here little b equals 21 sine 66 over sine 79. Let's put that into our calculators. Let's round to two place values. Alright, here are our solutions. We got little a is 12.27, little b is 19.54, and angle B is 66 degrees. So when we're solving the triangle, we're looking for all these components. So let's just put this in a box, and that's our solution. Okay, so let's recap. So here the instructions are saying for the given triangle, find the length of side A and C. In order to find A and C, I need to find B to have this complete proportion, right? So we're going to do 180 minus 87, that's 93, and minus 25, we get 68. So this triangle in here, 68 degrees. So now I'm interested, I have a complete proportion. I have side B and angle B. So I'm going to set that equal to my proportion for the side A, angle A, and side C, angle C, in order to solve for C and A. Okay, so let's set that up. So we have our complete proportion, 14 over sine 68, equals, let's do little c over sine 87. And I'm going to go ahead and I'm just going to set up my proportion for A as well. And now I'm going to take this and I'm going to re-express it to isolate C and A. Here we get C equals 14 sine 87 over sine 68. And then we're going to put that in our calculator. And here we get A equals 14 sine 25 over sine 68. So let's go ahead and put that in our calculator. Okay, so after we put both of them in our calculator, for little c, oh, we were in inches, weren't we? Okay, so we have these two symbols here that were given in our triangle. That's a prime symbol. When I have 2, it's inches. When I have 1, it's feet. Okay, and then let's go ahead and put that in as well. All right, so now we're going to talk about the ambiguous case. So the difference, remember, we've been talking about side, angle, angle, triangles. So we had a side given and 2 angles that weren't between the side, and then we also had angle, side, angle. And there was no question that the third angle had to have been this plus this and subtract that from 180 for both these type of triangles. However, let's take a look. In the ambiguous case, I'm going to have 2 sides and 1 angle. So there could be a slight variation and we can have different types of solutions. All right, so where is this coming from? Let me show you. All right, so here's the triangle I was referring to. So let's say I drop an altitude here, going back to the proof, and I wanted to find the sine of A. It doesn't matter which triangle I'm looking for. Sine of A, now because I created that right angle, is equal to opposite over hypotenuse, and I can isolate H, and I get H equals sine B sine A. Okay, I'm actually going to use this to determine, do I have one triangle, whether it's this acute triangle or this obtuse triangle? Do I have a right triangle, because either one of these scenarios could be happening? Do I not have a triangle at all? So it could be that I just have something that looks like this, an incomplete triangle here, okay? Or do I have 2 triangles? So here are some formulas. All right, so we look on the far left. You have one triangle when A is greater than H and A is greater than B. So what we need is that formula that we just wrote, right? We drop the altitude, we call it H, we're going to solve for sine A, and that's where that's coming from. So now we're going to take this proportion of H, A, and B and determine how many triangles do we have, or do we have one at all. So again, we have one triangle when A is greater than H and A is less than B. Or it could be that we have one right triangle, because it all depends on that proportion of A, B, and H. Okay, so if A is equal to the height that we dropped, we don't really have a triangle that looks like this. We have a triangle that looks like this. So when A equals H, it's a right triangle. However, it could be that we have something funny that I was trying to draw before. I could have this going on. So when A is less than H, so let's go ahead and write that so that way it's easier to memorize. And basically it's not long enough to form this triangle, so it's incomplete. So you have no triangle. And then the last one, the one that's a lot of fun to calculate, is this 2 triangles scenario. So it could be that you have these 2 triangle scenarios. When does it happen? It happens when A is greater than H and A is less than B. So I just want to point something out. Let me zoom out. Notice in both of these, you for sure have a triangle when A is greater than H or when A equals H. So as long as A is greater than H, you have triangles. What determines whether you have 1 or 2 is the relationship between A and B. If it's greater than 1, if it's less than 2. If A equals H, you have a right. And if A is less than H, it's not long enough. You don't have a triangle at all. So let's start looking at different examples. All right, so here's our first example. It says, for the given triangle, find the length of B and angle measurement of B. Okay, so before you begin, remember what we want to do is we want to compare H, B, and A. And in order to create that comparison based on what I just said a moment ago, we're going to need to solve for H equals B sine A. So you want to look at the given and determine, do you have enough information? So you need little b, but that's not given. I have to solve for it, and you need angle A, and we have that. So I can't start here first. Typically, you want to start here first if you have this information. We don't, so we kind of have to continue with this triangle. So if I'm continuing with the triangle, I'm going to set up the only proportion that I possibly could. And this goes back to what we were talking about before. I have a complete proportion here with A. I have side A. I have angle A. And I have I have side C. And the only thing I could solve for here is angle C. That's where I must go here. Okay? So let's go there. Because I'm looking for angle C, I'm going to flip my ratios, and this is what I was talking about before. So sine C over side C equals sine A over little a. So I flipped them so that way I don't have to confuse that cross multiplying. What do I have to switch over? I think it's easier just to multiply both sides by 12, and then we can go ahead and rewrite it. Sine C equals 12 sine 81 over 20. And how are we going to get angle C by itself? How do I get rid of this sine that's attached to it? Good, we're going to take the inverse, right? So that's arc sine. So let's go ahead and rewrite it. C equals arc sine of everything that we have in parentheses. Really important to put what you have in the parentheses first and then take arc sine of that, so that way you don't do an error on your calculator. So tell me what you get for angle C. All right, so we're approximating, this is an approximation, and let's round it to the nearest degree, so we get 36 degrees. So let's put that in our picture. So 36 degrees. And again, I can't determine whether I have 1, 2, or none, or a right triangle just yet, even though I'm given a picture. In your homework, you won't be given a picture. It'll say A equals B equals, and then angle whatever they give you equals, okay? Draw a picture to help you out, but you don't know whether you have 1, 2, or none until you compare A, H, and B. So here, I don't have B yet to create that comparison. So what I need to do is suspend that concept of having 1, 2, or none temporarily and proceed as if you have one, so we can find what angle B is and side B is. All right, so let's do 180 minus 81 minus 20, and we're going to get, it's minus 36. 99 minus 36, 63 degrees. So it could be that this is 63 degrees, but remember, we just discussed that we could have 1, 2, none, or a right triangle here, right? Okay, so it's tentative right now because I need to find B in order to determine, was this a for sure triangle? Okay. I just want you to get into the habit of doing that, because in just a moment we're going to get different types of solutions. So let's solve for little b. Notice that this time I'm going to put it at the top. I'm going to set up b over sine b equal to 20 over sine 81. And then let's do b equals 20 sine 63 over sine 81. All right, good. B equals 18.04 inches. I know that because of these symbols here. All right, so now I actually do want to do H equals B sine A to make sure that the triangle I did solve for is in fact a triangle. Okay, so let's go ahead and do that. So here, B, we got 18.04, so H equals 18.04. Sine for A, 81 degrees. And let's put that into our calculator. H equals. All right, so we get 17.82, and now I want to go ahead and compare inches again. compare A, B, and H. So A is 20 and H is 17.82. Remember, I said if A is greater than H, you for sure have triangles, right? What determines whether we have 1 or 2 is the relationship between A and B. So now let's take a look at that. A was 20 and B we said was 18. A is greater than B, and I said when A is greater than B, you have 1 triangle. So this is for sure a 1 triangle scenario. And these are your solutions. Here's B, because that's what we were solving for. This is no longer a question mark. That's for sure 63 degrees. And this is for sure 36 degrees.
So A is greater than B.
All right. So again, this is very ambiguous because remember, we don't know whether it's a triangle just yet. Why? Because I have side angle. And that's our ambiguous case. I have to determine, do I have 1, 2, none, or right? And in order to determine that, remember, we need to compare A, H, B. And in order to find H, remember that formula is H equals B sine A. And I said to start here if possible. In our previous example, we couldn't start there. Here, I most definitely can. Let me draw your attention. I have sine A, I have B, I can most definitely solve for H. So that is exactly where I'm starting. Okay, because even though they're drawing a picture for us, we don't know whether we have a triangle, and we don't know whether it's 2 just yet. Okay, so let's go ahead, solve for H. So H equals B sine A, 15. Sine 69, let's put that into our calculators. Okay, we get approximately 14, and again, we're in inches, so 14 inches. And now we're going to compare A and H. So 12 in comparison to 14. 12 is clearly less than, so A is less than H. What did I say happens when A is less than H? There's not even a triangle here. So even though they drew a beautiful picture for me, that's misleading. Right? So be careful even though a picture is given. So this one's no triangle. So even though the instructions are telling me to find the measurement of angle B, I can't because this triangle doesn't exist. All right, so here we're given, we're solving the triangle. We're given A equals 12 meters. B should also say 31 meters. That was a typo on my end. And angle A is equal to 20.5 degrees. All right, so now that I have that, I have enough information to do H equals B sine A, don't I? Yes. So that's exactly where I want to start. So let's go ahead and actually start there. So H equals B sine A, direct substitution. B is 31 meters and A is 20.5 degrees. So here we get, good, here we get 10.86. And now let's create a comparison. Let's start by A and H because remember that one's going to determine whether we even have a triangle or not. So here, is A greater than H? A less than H? A is greater than H. 12 is greater than 10. So therefore, so far I've established that I have some triangles. I either have 1 or 2 at this point. Now we're going to compare A and B. 12 to 31, which one's greater? B. So here A is less than B. When this is the case, you have 2 triangles. So let's take a look at what could happen when you have 2 triangles. So let's draw what you're given. You proceed as if that's your first triangle. So triangle 1. So let's draw a picture. Here's A, B, C. 20.5. Little a equals 12. Little b equals 31. The only thing I could logically solve for right now is angle B. Does everyone see that? Okay, so we're going to use the law of sines to set that up. So that's where we proceed to next. So let's go ahead. We have sine B over 31 equals, and my complete proportion is sine A over 12. Now I'm going to isolate sine B, but this time I'm going to do something different because I want us to think about something. I'm going to leave sine B just where it is. And I'm going to put this into my calculator. So let's go ahead. Let's say sine B equals, let's see what we get. Good, we get 0.9047. Okay, so where could these two triangles be coming from? Well, let's explore it. Let's go back for a moment. The unit circle. If I said sine theta equals a half, doesn't theta correspond to two possible solutions? Okay, theta could equal what? Pi over 6, good, and theta could also equal 5 pi over 6. So you have these two possible solutions, these two angle measurements, all right? Same thing's going on with that 0.90 that we got for sine of B. So it could be that we're hanging out over here for the 0.90 ... whatever it was. Or it could be that we're hanging out on this side, that it's extending all the way over here, and then I have my triangle that's in here. Well, remember, we're interested in this reference angle. So in order to get that, let's see what we have to do. So let's pick up where we were just a moment ago. All right, so this is where we left off. So now when I hit arc sine of that in my calculator, I'm going to get, let's round to the nearest degree, angle B, and let's call it B1 because we've established that we have two triangles, is approximately 65 degrees. Or this could be a reference angle in quadrant 2, right? So I have to actually go ahead, yeah, for our other triangle. So I do for triangle 2, what we do is 180 minus angle B1, that's going to be angle B2. So I'm going to do 180 minus 65, and I get 115 degrees. So now I have my two triangle situation. And let's go ahead and draw those two triangles. All right, so here are my triangles. I doubled up the given on both of these. So this is the given that we had. We had angle A, we had little b, we had little a. What we just found was B1 was 65 degrees. These triangles are clearly not to scale. And this is 115 degrees. Okay, so what I'm missing in the first triangle, so now I proceed as if I had two triangles. And I'm looking for little c and angle C in the first triangle, and then we're going to look over here. We're looking for C2, side C2, and angle C2. Let's start with our angles because I think those are the easiest to solve for. So let's look for angle C1, and that's approximately, because angle B1 is approximation, 180 minus 65 minus 20.5. That's 94.5 for angle C1. Let's go over here, angle C2. Approximation as well, 180 minus 115, that's 65 minus 20.5. We're going to get 44.5 degrees. And now we're just missing little c on each, so now this goes back to what we did before, our basic law of sines. So if I'm looking for little c1, I'm going to put that over angle C1 over a complete proportion. In order to establish consistency and make it easier on myself, I'm going to use the given on both of these. So you don't have to pick that. 12 over sine 20.5. And here we have little c over sine 44.5 equals the given, 12 over sine 20.5. Put this into your calculator. C1, C2 equals. All right, so this is what we get. We put that into our calculator, 12 sine 94.5 divided by sine 20.5. Remember, I gave it to you in meters, so 34.16 meters. And here we're putting into our calculator 12 times sine 44.5 divided by sine 20.5, and we get 24.02 meters. All right, now let's talk about the area. This is easy, I promise. Easy in the two triangles. When we're looking for the area of an oblique triangle, basically, let's take a look at the formula. The area is equal to half, and I have two sides. So if I have A and B, then I'm going to use the sine of whichever side I didn't use. So that's going to, if I used A and B, I'm going to take sine C. If I have A and C, I'm going to take sine B, and that's what you see here. If I have B and C, I'm going to take sine A. So it's always the angle of the side I didn't have, okay? For example, find the area of the given triangle. So let's make sure we have the criteria. I have side B, side C, and I do have an angle That's not those sides, so that's exactly how I'm going to find the area. So area is equal to half times those sides times the sine of 71 degrees. Put that straight into your calculator. Make sure you're in degree mode. So here our area is 14.18 square inches, or however you want to write it, square inches. I put the squared backwards. All right, let's apply this. All right, two fire lookout towers are 17 miles apart. So here's the first tower, here's the second tower, 17 miles apart. With Tower A directly west of Tower B, so now I know where to position A and B. Both towers spot fire to the north. Here's my fire to the north. The bearing from station A to the fire's north, 55 degrees east. So let's recap bearings real quick. Remember, I'm not going to give you pictures, so what I like to do is create this north, south, east, west axis. Remember, you always go from the North Pole and then you go out east. So this is your 55 degrees. That's your bearing. In order to get it inside the triangle, you have to do 90 minus 55 to get that 35 degrees. And we're going to do the same thing for the bearing from B to the fire. That's north, 40 degrees west. So I'm going to go north. Here's my north, south, east, west pole. I'm going to go northwest. So this is 40 degrees here. In order to get the angle inside the triangle, you do 90 minus 40, and that's where that 50 is coming from. And then it says, be careful here. This is a part where you have to make sure you draw yourself a picture. How far to the nearest tenth of a mile is the fire from station A? So I'm not interested in little a, which is over here on this side. Right here, I'm interested in how far the fire is from station A, which makes it, what I'm looking for is little b. So if I'm looking for little b, that's the ratio I'm going to set up. But in order to set up a complete ratio, I need to find angle C. So 180 minus 50, 130, 130 minus 35, that's 95 degrees. Okay, and now let's set up our ratio. Again, we're interested in little b. B over sine of 50 degrees equals the complete ratio C over sine 95. So notice that if I didn't draw a picture, I would have been incorrectly solving for little a, and that's how far the fire is from station B. So make sure that you're reading that and drawing an appropriate picture. So let's do 17 sine 50 divided by sine 95. How far are we from the fire? B equals 13 point, let's round to the tenths, 13.1 miles. So that's how far station A is from the fire, even though I just found side B.